2025 was framed as the year autonomous agent swarms would finally take over the heavy lifting of enterprise operations. The goal was a digital workforce where specialized agents functioned as a single department, researching, coding, and negotiating in a continuous automated loop. But as these agents began interacting, small interpretation gaps turned into structural logic errors. A single mistranslated requirement could propagate through 10 different agents, leading to the confident execution of projects based on business processes that simply didn't exist. These failures weren't the result of unintelligent models. Individually, the agents were capable. The breakdown occurred in the space between them. We built a powerful engine for an autonomous workforce, but we didn't build any traffic laws. In an enterprise environment, relying on the probability of a language model leads to cascading chaos. The vulnerability lies in the communication layer. Early agent systems relied on natural language handoffs, essentially asking one AI to talk to another to figure out the next step. Every handoff was a statistical guess, a calculation of what the model believed was the most likely interpretation of the previous agent's work. Everything falls apart when a single agent makes a minor reasoning error. The next agent accepts that error as fact, building its work plan on that flawed foundation and passing it forward. Because probability compounds, that tiny deviation rapidly morphs into a massive system-wide hallucination. This compounding amplification is known as stochastic drift. Refined prompting cannot fix this. A prompt is ultimately just a suggestion, but mission-critical systems require absolute guarantees to function. Solving this requires moving away from open-ended reasoning and toward a framework called deterministic orchestration. This replaces conversational handoffs with structured data contracts. Agents exchange validated schemas. Developers define every transition path before code runs. The AI operates on strict railway tracks. If an output fails validation, a failsafe triggers, isolating the error at its origin before it drifts. By hard-coding the workflow logic, the system guarantees the execution path. The AI provides the creative reasoning within the task, but the architecture that connects those tasks remains rigid and immutable. This level of control is the only way to scale. Human oversight can manage a few dozen AI decisions, but it cannot supervise 10 million automated actions happening simultaneously. Deterministic orchestration replaces manual spot checks with automated verification and real-time telemetry, creating a permanent audit trail for every decision the swarm makes. This shift also changes the cost of AI. Instead of running one massive, expensive model to do everything, companies can deploy hundreds of smaller, specialized agents to handle discrete, narrow tasks. Coordinating these specialized agents through a deterministic controller results in lower operational costs, delivering faster processing and higher reliability. Future dominance belongs to the organizations that prioritize the engineering of reliable control systems. Intelligence without a verifiable steering mechanism is simply high-speed unpredictability.